4.1, product and quotient rules. Okay, let's take a look at some derivative properties, and then we'll add some new rules. First property is the variations of the look of a derivative. Okay, let's say you have a function f. One way, common way to write the derivative of this is by using a prime right here on the f. A second way is by taking the function and encasing it in a parenthesis and putting a prime on the parenthesis. They both mean the same thing. You're still taking the derivative of f. Secondly, you can have the function f here and make it into df over dx. This represents, again, a derivative of the function f. Or, there's one more way. You can write d over d of x, and then here off to the side, put in f of x. And that's also the derivative of the function f of x. We have the power rule, which says that if your function f of x equals ax to the n power, then the derivative will be n times a all to the x to the power of n minus 1. A new rule is going to be called the product rule. The product rule says if you have two functions that are multiplying, and you want to take the derivative of the functions while they're multiplying, then the derivative will be the derivative of the first function times the original second function plus the original first function times the derivative of the second function. This is the product rule for taking the derivative of two functions while they're multiplying. Next is the quotient rule. The quotient rule takes two functions that are dividing, let's say f of x over f of g, and it says if you want to take the derivative of two functions while they're dividing one another, then the derivative will be this. The function in the denominator will go to the left, underneath, and to the right. The one to the left will be the original g, but the one on the bottom will be squared, and the one on the right will be a derivative. Next, the function in the numerator, the derivative of it will go here, minus the original function f of x here, times the derivative of g of x. And this will be your quotient rule. Okay, next example. We're going to take a derivative of this function, y equals x squared minus 3x plus 4, times x squared plus 5x minus 1. And let's use dy over dx to show that we're taking the derivative of y. So this will be the first term, since these are products of each other. So the first term, derivative, times the second term, x squared plus 5x minus 1, plus the original term, x squared minus 3x plus 4, times the derivative of x squared plus 5x minus 1. Okay. Now, the derivative of x squared plus 3x plus 4 will be 2x minus 3 times this function x squared plus 5x minus 1. Okay. The derivative of this function here, the 2x squared plus 5x minus 1, will be 2x plus 5 times the original function x squared minus 3x plus 4. And that's your derivative of y. Next, we want to take the derivative of this function, 4x squared times x squared minus 5 times x squared plus 4x. And here we see four products. We'll still use the product rule. Okay, so, and let's use the df of x all over dx for the show the derivative. So let's take the derivative of just the 4x squared times both of these, which will be 4x squared derivative times your x squared minus 5 times your x squared plus 4x. Plus, this time we'll take the derivative of this function times these two, which will be 4x squared times x squared minus 5 derivative times x squared plus 4x. Plus the derivative of this function times these two functions, which will be 4x squared times x squared minus 5 times the derivative of x squared plus 4x. Okay, now, the derivative of 4x will be 8x. Sorry, of 4x squared will be 8x times x squared minus 5 times x squared plus 4x. The derivative of x squared minus 5 is 2x plus 0. So this will be 4x squared, and this will be a 2x times your x squared plus 4x. Now the derivative of x squared plus 4x is 2x plus 4. So we'll have 4x squared, x squared minus 5, and 2x plus 4. Now that we've taken the derivative, we'll start cleaning this up algebraically. Okay, let's move this over a bit. Alright, we can take an x out of this term and combine it with the 8x and get 8x squared times x squared minus 5, and the x out of this leaves x plus 4. Okay, here we can factor out an x out of this and get x plus 4, and we can combine the x with these two. So what we'll get is a 8x to the 4th times an x plus 4. And finally, we can factor a 2 out of this and get a 2 times the 4x squared, which gives us 8x squared, times x squared minus 5 times our x plus 2. Okay. All right, let's take a look at number 3. Number 3, you have 4x plus 5 all over 3x minus 4. We want to take the derivative of the function g of x. So we'll use the prime notation here. And 3x minus 4, we'll put it here, 3x minus 4, and here, 3x minus 4, and here, 3x minus 4. 3x here will remain as the original. 3x minus 4 here will be squared. 3x minus 4 will take a derivative here. And the 4x plus 5 will take a derivative here times the 3x minus 4, and then minus 4x plus 5 times the derivative of 3x minus 4. Okay. The derivative of 4x plus 5 is 4 plus 0. So that's 4. So 4 times 3x minus 4. And the derivative of 3x minus 4 is 3 minus 0. So we'll say 3 times the 4x plus 5. And that'll all be over 3x minus 4 all squared. Now from here we're going to distribute the 4 and the negative 3. This will give me 12x minus 16, and this will give me negative 12x minus 15. Okay, and from there, it's all still over 3x minus 4 all squared. The 12 x's will cancel, and the negative 16 and negative 15 will combine for a negative 31 all over 3x minus 4 all squared. Next, let's take a look at number 34 on page 304. We want to take the derivative of y. Now, before we do that, I want to change all these terms into to give them exponents, so we can make sure we can use the power rule. So, y equals 4x squared minus x to the 1/2 power times x to the 1/2 power minus 2x to the negative 2nd power. And from here, I'll start taking a derivative. And we're going to use the product rule. So, dy will over dx will be 4x squared minus x to the 1/2 power derivative times the original term, x to the 1/2 minus 2x to the negative second power, plus 4x squared minus x to the 1/2 power, the original, times the derivative of the second term, which is x to the 1/2 minus 2x to the negative second power, derivative. Okay, so the derivative of this will be 8x, the derivative of this will be negative 1/2, and 1/2 take away 1 will be negative 1/2. Okay, then this remains the same, x to the 1/2 power minus 2x to the negative second power. Okay, and this remains the same, 4x squared minus x to the 1/2 power. Now the derivative of this will be 1/2 x, and subtract 1 from the exponent, we get negative 1/2. Then negative 2 times negative 2 is positive 4, and subtract 1 from the negative 2, we get negative 3. Okay, so this is our derivative. Now we're going to clean this up a bit and go back to our roots and our positive exponents. So this will become 8x minus 1 all over square root of, so 1 over 2 times the square root of x. This will be the square root of x minus 2 all over x squared plus 4x squared minus the square root of x. And this will be 1 over 2 square root of x plus 4 all over x to the third power. And this will be the derivative of y with respect to x. Next, number 44. We want to take the derivative of y, which is square root of x minus 1 all over square root of x plus 1. Again, we're going to turn all the roots into exponentials so we can use the power rule. So y equals x to the 1/2 power minus 1 and x to the 1/2 power plus 1. And now we'll start taking the derivative. So we say the derivative of y, so y prime, will be x to the 1/2 plus 1, x to the 1/2 plus 1 squared, x to the 1/2 plus 1 derivative. And now the numerator will go here and here. So x to the 1/2 minus 1 derivative minus x to the 1/2 minus 1. Okay, furthermore, we want the derivative of this term and this term. So we'll have x to the 1/2 power plus 1. The derivative of this is 1/2 x to the negative 1/2 power minus 0 minus x to the 1/2 power minus 1. The derivative of this is going to be 1/2 x. And 1/2 take away 1 will be negative 1/2. And then derivative of 1 is 0. And that's all over x to the 1/2 plus 1, all squared. Okay, now let's distribute these terms. The 1/2 x to the negative 1/2 times the x to the half, we're going to have to combine numerators. Should I say combine exponents. For instance, if we have x to the second power times x to the sixth power, we get to add exponents. Well, here, this is x to the 1/2, and this is x to the negative 1/2. So when we add those two, we get 1/2 and a negative 1/2. We get x to the 0. And x to the 0 is 1. So this x to the negative 1/2 times this x to the positive 1/2 is 1/2 times 1. Then the 1/2 x to the negative 1/2 times the 1 gives us positive 1/2 x to the negative 1/2. Okay, here, 1/2 x to the negative 1/2 times x to the positive 1/2 will again times negative will be negative 1/2 x to the 0. and x to the 0 is 1. 1/2 x to the negative 1/2 times the negative 1 times the negative is positive 1/2 x to the negative 1/2 power. And all of this is still over x to the 1/2 plus 1 all squared. Alright, from here, we can start collecting like terms. The 1/2 times 1/2, 1/2 times 1 minus the 1/2 times 1, those cancel. Furthermore, we have a half of an x to the negative 1/2 and another half x to the negative 1/2. When you combine those give you a whole x to the negative 1/2 power. And that's all over x to the 1/2 plus 1, all squared. Okay, that's about as simplified as we can get it. Let's start removing these negatives and the half powers. So what we'll get is 1 over the square root of x and times the square root of x plus 1 all squared. And this is your derivative for y. Next, number 68. Number 68, we have a function here, and we want to find out what is the equation of a line that's tangent to this function at x equals 1. Well, let's take a look at what this function looks like in the first place. Okay, I can see it has a y-intercept of 0, 0. It also has a horizontal asymptote of y equals 0. And on the left side, negative over negative squared, it's going to be all negatives. So, get this. And on the right side, positive over positive squared is going to be positive. So, our graph will have that type of look. Now, at x equals 1, we want to know what equation would we get if we set a line right through 1, tangent to the graph. So the question is, what is the linear equation for that line? What is the linear equation for that line? To find that, we need to use the point slope formula. For this point slope formula, we'll need a point. And we'll need a slope. Okay. So, for a point, we can plug in x into this equation and get the y coordinate from there. So let's do that. So, f of 1 equals 1 over 1 squared plus 1, which is 1/2. So the point here, there, will be input 1, output 1/2. Now to find the slope at that x equals 1, we need to take the derivative of the function. So, let's take a derivative here, and we're going to have x squared plus 1 all squared, x squared plus 1, and x squared plus 1 derivative. Here we'll have x derivative minus x. The derivative of x is 1, so it'll be 1 times x squared plus 1. The derivative of x squared plus 1 is 2x, so this will be 2x times the x. And all that will be over x squared plus 1 squared. Alright, this cleans up a little bit. We can get x squared plus 1, and negative 2x times x is minus 2x squared. That's all over x squared plus 1. This will clean up once again. We'll collect like terms, and we'll get 1 minus x squared all over x squared plus 1. Alright, so this is the function derivative of f. Now we want to place the 1 into the function and find out what kind of slope we're going to have. So this will be 1 minus 1 squared all over 1 squared plus 1 all squared. Okay. this is going to give us 0 over 2 squared, which is 4. So we'll have a slope of 0. Okay, well, if the slope is 0 and you put the numbers in, you get y minus 1/2 equals m x, sorry, that'll be 0, x minus 1. Well, 0 times anything is 0, and when we add the 1/2 to both sides, this isolates y to y equals 1/2. And this is the equation of this line. Okay, let's take a look at number 70. Number 70 says, the monthly sales of Sun Electronics' new iSun Walkman is given by the Q of T equals this equation here. This is the demand function. How many items people are taking off the shelf of your product? Next, what T represents the month after its introduction. The price Sunny charges is this equation right here. And again, T is the month that you're into after the introduction. Now, they say find the rate of change for sales, for the rate of change of price, and the rate of change for monthly revenue 6 months after the introduction of iSun, and then interpret the answers. So what's the rate of change for the sales? Well, that's demand. Demand is sales, or how many items people are buying from you. So the derivative of that will be 2,000 minus 200t. This will be the rate of change for your demand. The rate of change for the price will be negative 2t. Now, they ask, well, what is the rate of change after t months, or 6 months? Well, if we put 6 in here, we'll get 1,200 from 200, which is 800. That 800 represents a slope that output is items with the input of months. So at the 6th month, I know they're coming off the shelves at about 800 items per month. And again, that's at the 6th month. Don't know what's happening at the 7th month, but I know at the 6th month, we got about 800 items coming off the shelves at that instant. Now, what price are we selling these items? Well, at the 6th month, our price is negative 12. This derivative comes from the output of money, input of months. So, the price is going down 12 bucks that 6th month. So whether they were selling at $100, they're now selling at 88 bucks. So they're going down at the 6th month. I don't know if that's good or not for the price to be coming down like that, but we are selling 800 items. Now let's talk about our profits. Not profits, but revenue. Revenue comes from multiplying the number of items people are taking off the shelf times the money that they're giving you for each item. So, quantity times price. This gives our revenue. Now, they want the derivative of the revenue, which will be the derivative of Q times P plus Q, original Q, times the derivative of P. In this case, we already have our derivative of Q, which is 2,000 minus 200t. P is going to be 100 minus t squared plus Q. Q is 2,000t minus 100t squared times p prime, which is negative 2t. Okay, so our revenue function at the 6th month, I have to put 6 in here for all these t's, so this will be 2,000 minus, let's see, 6 times this will be 1,200, and 6 times this will be 36, so this will be 100 minus 36, and 6 times this will be 12,000, and 6 times this is 36 times 100, which is 3,600, and 6 times this is negative 12. Okay, let's put all this in the calculator. So we have parentheses, 2,000 minus 1,200, close parenthesis, open parenthesis, 100 minus 36, close parenthesis, plus, open parenthesis, 12,000 minus 3,600, close parenthesis, times, open parenthesis, negative 12, close parenthesis. Okay, according to this, we have a negative 49600. Now, this is a derivative, so this is basically a slope, rise over run. The rise, the output for revenue is money. And the run, or the input for this, will be months. So, what this tells me is that my revenue, I'm losing about $50,000 in revenue at the 6 months. $50,000 per month at that instant. Maybe at the 7th month, I'm losing less money, or maybe I can find a place or a month where I'm not losing money at all, or maybe finally gaining money. But right now, at the 6th month, I'm losing close to $50,000 bucks.